Hey, welcome back. So I have soldered the toroid winding to the SO239 as discussed here, right? As discussed, this one is going to the ground. Basically, you can attach a counterpoise here, and I've taken this wire and going to the shield ground, and we need to attach the 100 PF capacitor between the center pin of SO239 to the shield, or the you can attach it either here or here. So what I did was, for solder, these are pretty thick wires. My 25 watts soldering iron won't do the trick. So I took out my 80 watts solder on and then soldered this, right, and then soldered this as well. I put a lug nut. What you need to do is take a lug nut and then file it off like I showed you earlier, and then put in the solder. It will hold. Otherwise, these lug nuts, they don't hold. It's better if you get a steel lug nut. I do not find anything otherwise. Anyway, if you are putting this in a box, it's pretty safe, and it lasts for years. If you are planning to put it outside, it might get rusted. So anyway, I've added the capacitor here, and the rounding, as you can see, it's pretty nice. I've added the toroid onto the, sorry, I've fixed the toroid onto the board by using three cable ties. Pretty basic, nothing much here. I've added this, so this goes to your aerial. So for testing purposes, what I've done is I've added the spot fixed at 2.450 ohms, 2450 ohms, not 2.0, 2450 ohms or 2.4K onto the ground, the shielding, and it's a temporary solder, but it's holding, and to the antenna, right, antenna radial part. So once you have done that, I have my nano VNA here. We can quickly measure. You will never get the full flat reading here. What you need to do is, to get a good reading, you actually need to take a resistor and put across these 2 points or these 2 points, either way. Um, because if you use a pot and such long wires, I mean, these are pretty, I do not have the resistors, so I'll just connect it to my nano VNA here. There's a patch cable I've got made so that I can connect directly to the nano VNA without any connectors. So if you look at the reading here, on 70 meters between 6.9 megahertz and 7.3 megahertz, it's a pretty flat 1.175. You can just take the marker and run it across. It's a pretty flat. As you can see, the ohms is 42 ohms, very close to 4 ohms. Uh, what will happen is, if you change the thing to 14.4 megahertz, your SWR goes from 2.3 to 2.4 megahertz. This is pretty much the standard reading I get every time I do this. But moment you put a 19.5 meters, 2.5 square mm or 1.5 square mm, the thicker the wire, you can reduce it a little bit. Like I said earlier, you need to tune it. So another way to look at it is, let's say you're on 40 meters. Let's go back to 40 meters here. You're on 40 meters, and you will see a nice curve. Okay, let me select 3.5 to 30 megahertz. You see this curve here? It's pretty much goes out after 17, I think 15 megahertz, right? 16 megahertz. Okay, it goes out at 16 megahertz. Goes to the top at 3 point something. Don't worry about that. It'll still work for 10 meters. You just need this resistance setup is not correct. Not It's not correct, but it's not favorable for these kind of measurements. What will happen is, let's say your curve, right? Let me select this. Okay, better is this. So let's say you have a curve like this. I think it's better I write it down so that you can see what I'm trying to say. So if you have got a dip at in the SWR meter like this, if you have got a so this is your line. This is 7.0 megahertz, 7.5. This is 7.1 and 7.150. Right? If you have got a dip here, right? It's a pretty good dip, and the higher the square mm wire you use, the wider the dip will be. Bandwidth increases. So if you use 2.5 square mm, assume this is the bandwidth you have. If you use a 0.75 square mm, your bandwidth reduces. If you use a 4 square mm wire, your bandwidth increases. This becomes almost like a big U, right? Now, how do you tune it, right? If you decrease the length, right? Decrease the length of the wire, this moves towards higher bandwidth. So if you decrease, this will move towards 7.2. If you increase, okay, increase the wire, it will move towards this side, right? That's how you tune. This decrease and increase is standard even in if you're tuning a dipole, right? If you decrease the wire length, the frequency move towards your right, towards higher, or rather lower bands or higher frequencies, right? If you increase the length of the wire, it moves towards lower frequencies but higher bands, right? So remember this formula, right? Decrease to move right, increase to move left, right? So this is a good, way to remember how to tune the antenna, right? So don't worry about the nano VNA readings; it'll work. This is all you have to do. Your winding should be right, and you should solder the center pin to the SO239, connect a capacitor, connect the ground, to the counterpoise onto this. Some people, what they do is they connect the ground directly to this and then pull a wire. This is what I've done. Pull a wire to the counterpoise. What I've done is I've put this on the counterpoise and then connected it back to this. Same thing, it'll still work. You can do this winding a little bit tighter, it'll work. But this will work perfectly. Unfortunately, I don't have a wire, but if you ever get onto a field day ops, we can test it out. That should not be a problem. Okay, thank you very much for watching till now. This has been a great experience, and I hope you build your own end fed. I'll just yank this off. Okay, I need a cutter. Okay, so if you have any questions, reach out to me. I'm at vu3gwn@outlook.com. Yeah, just to go over what we have discussed so far. Initially, I've given some theory on what is NFEDs, how does it work, right, and all those things. And then we talked about materials, what materials you need, where to get it, approximately how much does it cost. Then we talked about, where I showed you all the materials laid out in front of you, what all you need. These are pretty much right. And then we talked about how to wind this, and then showing you the soldered one. I didn't want to waste your time showing soldering as well, so I did the soldering. It's come out pretty good. As you can see, at least on 40 meters we are 1.2 and less. So but you add a 19.5 radiating element, 19.5 meters, not feet. I'm pretty sure you will get a clean SWR less than 1.3 across all bands, guaranteed. Yeah, if somebody knows why I get the SWR high after 16 megahertz, please drop a note in the comments. I'll look it up. There are certain videos on YouTube where they get a pretty much flat SWR line across all the bands. I've tried it. I cannot duplicate that for whatever reason. Anyway, so but that kind of SWR reading where at 16 megahertz it goes up top, to the threes. It kind of made me sad. But when I tested with wires, I have not tested just one. I've tested multiple toroid windings. I've tested multiple transformers, and all of them have given me great SWRs. Less than 1.3. Up to 10 meters, so I know this works. This is the result I kind of expected from the nano VNA itself, and based on this I know this will work. So okay, thank you very much for spending a lot of time watching this video, and I'll come back with more great ideas and more great videos. Thank you very much. Have a nice day. Have a nice evening.